Hello, we are Team Earthlingx, and this is our logos, as well as our project for HAcK 2022.
All right, so meeting the team, starting with the left, I am Laura Gonzalez. My major is electrical engineering, and I'm a transfer from Ventura College.
Hi, my name is Jingwen. I'm the remote person in the middle. I'm a computer science major and I'm transferring from De Anza College.
Hi, I'm Richard Sandoval. I'm the one on the right. I'm an aerospace engineering major, and I'm transferring from Moore Park College. Some objectives that we had for this project is we started with assembly. We were provided precuts of the robot blocky, which allowed for easier placement of inner components and less time on SolidWorks. Even though we did use SolidWorks for an arm, it just facilitated our use of it and allowed us for other objectives. So our next objective is wiring. We had to be able to wire all the components together, including the breadboard, the Arduino, the motor shield, ESP, servo motors, LCD, and the wheel motors. Our next objective was coding, which we had to develop a code to control the robot via Bluetooth, execute functions within Arduino, and use processing to detect keys pressed. Our next most important objective was testing, which required us to test the robot over and over again to make sure that the wiring, the coding, and the assembly were fully functional before taking it out into the field of play. And then the functionality is when we actually took it into the field of play and tested it out. So we started off with SolidWorks on Friday, making our version 1 of the arms, which is the top left picture. And keeping this in mind, we decided to laser cut everything in order to save time in case a part failed or needed to be modified. And we had to modify the original arm 2 times, once because it was too short, and the second time was because we downloaded an incorrect file for the servo motor. So the next couple pictures just highlight that change, and we had extended by 1.1 inches. The next photo shows the connection between the bigger arm and the smaller arm. And then the last two show the little arm and the final assembly. So we were going for efficiency, which is why we only had 4 laser cuts in the total assembly.
And this is the complete assembly with the arm connected to Blocky and SolidWorks. And so for aesthetics for our robot, we decided to go with a license plate type of design to glue on the back of Blocky's trunk. This is basically our team name with the picture of an Earth being replaced with the word Earth, and then the rest of our name just links all together.
We used Arduino and processing for the coding. Processing detects the keys we press and write to the Bluetooth serial port. And then ESP32 reads the data from Bluetooth and sends it to Arduino through UART. After Arduino reads data through UART, it will call the corresponding functions when the data is received. The image at the middle is our first draft for the wheels. It will use up to 12 digital pins to control 2 motor controllers to leave enough space for connecting LCD and servos. We decide to connect motors at the same side in parallel and keep speed by default. After the change, 1 motor controller and 4 pins are enough for 4 motors. So the reason we're doing all of the functions in Arduino Uno is that we want to call and combine the functions in the loop. And we also want to call functions inside of the other functions, such as dancing. The code at the left side is part of the code of the dancing function. So inside of the function, we called stop phase, move left, move forward, as the other functions to change the phases and change the wheel motions. It will avoid reduplicated coding. Our first draft for servos is a fast motion, but it may not be stable for picking up light parts with a fast motion and a sudden stop, such as the video. And this is the one we changed. It's a slower motion, so it can move smoothly. And to avoid repeating the same motion forever, you all receive a set to semicolon after each call. So we used both slower and faster motions for dancing. And we also declare a rhythm as an integer outside of the function. So it can be edited to fit into the music rhythm. The video is a sample that I tested at home.
Okay, I'm gonna unplug my pager. So part of this challenge competition is that we had to code different facial expressions for Blocky when they were moving forward, backwards, turning, and when it's stopping. So these are the different facial expressions we coded and created. This is the beginning when we barely started wiring the circuit with the breadboard. And then the picture on the left is when we completely wire everything from the servos to the LCD, everything all together.
Some circuit problems that we had while building Blocky was that the Arduino needed to remain connected at all times. This is not a Bluetooth issue. This was just some wiring issue that no one could resolve. And another problem that we had was the LCD face glitched at times, and the code would also run fine, but nothing would happen to Blocky. Some solutions to this problem was that we occasionally would switch the Arduino boards and upload them from different computers. We also constantly had to rewire the Arduino and ESP while checking grounds, double checking wiring, and at one point we ended up swapping the LCD because it just wouldn't work.
Some design problems that we encountered were the larger part of the arm that we designed was actually too short when we tried to throw in the game piece into Blocky's trunk. And because of this, it caused the little arm to not have enough clearance between Blocky's head and the little arm to safely drop into the trunk. And also the very tip of the little arm was too wide, so it didn't fit into one of the game pieces. A solution to this was that instead of rotating instead of rotating counterclockwise the little arm, we're gonna rotate it clockwise. Therefore, it could drop into it, the game piece could drop into the trunk, and then also we sanded down the tip of the little arm so that it would be able to fit into the game piece easily.
This is a 360 view of Blocky, starting with the top left, the front, then the left side, the right side, top half without the hood open, or with the hood open, and then the bottom picture is with our team logo, and then the last picture is just with our license plate design.
There's the functionality videos for driving forward, backward, left, and right.
You can
This is the one for making different faces.
And we know that it was really difficult to see the changing faces in the previous video, so we just took screenshots from that same video and posted them here.
And this is picking up both game pieces.
Okay, okay, okay.
Okay.
And this is dancing on its own by pressing one button.
Yeah, I'm ready.
As you can tell, our Blocky was a little excited to be doing the dance, but and some future improvements that we have for Blocky is to get the Blocky working without an external Arduino connection, make the first part of the arm longer and try for the original design once again, cleaner wiring to see mistakes, higher voltage batteries, improving hook for multi-purpose claw, additional servos, improving the code, and adding some solar panels.
Want to do a quick shout out and thank you to our sponsors and to our mentors. Thank you for our presentation.